Tēnā koutou katoa, e mihi ana ki anai tahu, te iwi mana whanua o konei. Ko te pōkoko mataraka o, ko Stuart Brock toko ingoa, no reira tēnā koutou, tēnā koutou, tēnā koutou katoa. My name's Stuart Brock. I'm the Deputy Vice-Chancellor Academic and I'm your host for this evening. It is my great pleasure to welcome you all to this very special occasion to celebrate the promotion of Tony Savarimuthu to Professor at the University of Otago. These lectures are a wonderful opportunity for us to come together and listen to our new professors talk about their personal journeys, their research platform, and the impact their research has had on others. I'd like to welcome colleagues, students and friends from across the university and beyond. I'd like to give a special welcome this evening to Tony's wife, Rexy, to his son, Rowan, to his daughter, Ria, to his sister, Sharmila, along with her family, and his brother-in-law, Robin, all of whom are attending here tonight to celebrate with us all. Finally, I'd also like to thank both of Tony's parents who are joining us remotely this evening via live stream. It's not easy to become a professor at the University of Otago. In order to be promoted to that level, candidates need to show that they are outstanding in each of three areas: teaching, research and service. Tony has clearly met all of these criteria. It's an honour and a privilege to congratulate him tonight for that outstanding achievement, and I hope you will join me now in doing the same. And I'll just note that if I wasn't holding this microphone, I'd be clapping loudly, so thank you very much. And I hope you'll take every opportunity to do more of that this evening. Tonight, Tony will share a little about his research into the social aspects of computing. Specifically, he'll discuss what it takes to create socially aware software, the socialness of the software development process, and how one can develop AI software for the overall good of society. Tony, though, will not only discuss his research this evening. He'll also reflect on his academic career to tell us a little bit about his own personal journey, about the impact of his research on the profession, on his teaching, and most importantly, on his students. But before he does that, I'll hand over to Professor Richard Barker, Pro-Vice-Chancellor of the Division of Sciences, to introduce Tony formally and give you a little more detail about his academic background. Thank you.
Professor Brock, tēnā koe. Professor Dick, tēnā koe. Professor Savarimuthu, tēnā koe. Friends and colleagues, tēnā koutou, tēnā koutou, tēnā koutou katoa. It is my great pleasure to introduce our speaker tonight, Professor Tony Savarimuthu, from the School of Computing, to give his inaugural professorial lecture here at the University of Otago. As Professor Brock indicated, Tony was promoted to professor in February of this year, and tonight we get to celebrate this significant achievement. Professor Savarimuthu was born in Tamil Nadu, the southernmost state of India and the home of the Tamil people. I didn't get much joy trying to dig out some early history on Tony, but he did report that as a young boy he learned Bharatanatyam, the state dance of Tamil Nadu, the oldest classical dance form in India, and perhaps tonight we're in for a treat. His journey to Otago was also something of a mystery, but from his employment record I can glean that he was a teaching assistant in computer science at BITS, there's a lot of acronyms in this subject, BITS, Pilani, India, for 2 years in the early 2000s. BITS stands for the Birla Institute of Technology and Science, and then a software engineer at Coral Grid Software in Chennai, then part-time assistant lecturer at BITS, again in Chennai, before appearing as a teaching fellow in the Department of Information Science here at the University of Otago from 2004 to 2006, at which time he then transferred to being a lecturer in the department from 2006 and onwards. Tony's PhD is from the University of Otago. He graduated in 2011 and was supervised by the husband and wife combination of Mariam and the late Martin Purvis. Tēnā koe, Mariam. Sister Shamila was also supervised by this team, which has led to some curiosities, including family member-only papers involving the Purvis and Savarimuthu families, and also a within-family publication where his sister and wife are co-authors, along with Tony as the only 3 authors on the paper. So when I read this, I thought I should go back and double-check as referees for this promotion. As Professor Brock has noted, promotion to professor at the University of Otago is far from easy, and one must excel in all 3 domains of academic activity in research, teaching and service. Professor Savarimuthu's research expertise is in agent-based systems which are vital to the development of robust artificial intelligence technology and applications, highly topical in the world we live in just right now. And I'm sure we're about to hear more about these agent-based systems and what they represent, so I won't provide a spoiler. To quote one of the referees for his professorial promotion application, his seminal work on norm identification continues to be highly cited, and his work in the area of multi-agent systems is highly impactful. A mark of the productivity of Tony's research is the output. He has 133 quality assured publications, most of which are first or second authored, and an H-index of 26. This research has also been recognised by his academic peers for its excellence. He received Best Paper Runner-Up Award this year for his paper Tackling Energy Poverty with Artificial Intelligence, Challenges and Opportunities at the Emergent Research Forum at the Americas International Conference. He won the Most Thought-Provoking Paper Award in 2023 for his paper Improving Information Systems Sustainability by Applying Machine Learning to Detect and Reduce Data Waste, that appeared in the Communications of the Associations of Information Science Journal. And he's also been recognised by this university. He received the Otago Business School Research Impact Award from the school in 2021. A significant feature of Tony's research is that most of its work is co-produced with his postgraduate students, which brings me to the next domain in which academics must excel, and that of teaching. Professor Savarimuthu's teaching efforts bookend the academic spectrum, being concentrated at both first year and postgraduate. He has supervised 13 PhD students, 5 master's students, as well as a further 12 honours projects. Included amongst the PhDs is a student whose work was recognised by entry onto the Dean's list of exceptional PhD research in the Otago Business School. A standout feature of Tony's undergraduate teaching is the personal evaluations of his teaching by students. Most of his evaluations score at a perfect 100% for effectiveness, something we rarely see from our big first-year class teachers. And this was maintained through COVID lockdown, a period when many of our students struggled with the online mode of teaching, and this was reflected in evaluations I'm privileged to see for other lecturers, but not Tony's. Well done. Unsurprisingly, his teaching has also received recognition, and in 2021, Tony was nominated for a Best Teaching Award and Best Innovation in Teaching in the Otago Business School. He was nominated for the Otago University Students Association Teaching Award in 2013, and then again in 2015. And this was for one of the large, about 500 students, and challenging papers that he and his colleagues have to teach, Business 106, a compulsory paper for business majors, and not an especially popular one. But the best tribute I can pay to Tony's teaching is in the words of his first-year students. Tony is an outstanding teacher. He really cares about his students and professional practice. One of the best teachers, extremely intuitive, and his lectures kept my interest for the subject growing. Tony genuinely cares about this paper and the success of his students, and I hope to have him as a lecturer in future courses at Otago. The final domain in which our academics must excel is service to the academic and professional communities. A significant source of service to the academic communities is via conference support. Professor Savarimuthu has served on the steering committee of the Prima Conference Series since 2014. He has been a program committee member for a number of conferences with A-star core ratings, including the AAMAS, the foremost conference in multi-agent systems, the AAAI, and the IJCAI. I did say there were lots of acronyms. He was local organisation co-chair for the top-ranked AAMAS 2024 conference, which is A-star ranked. For this work, he has also received recognition, winning Best Senior Program Committee Member Award at the 17th Principles and Practice of Multi-Agent Systems conference held in Brisbane, Australia in 2014. For the university, he has been a director of the software engineering program since 2018, convener for 6 Otago PhD theses, commerce representative on the Sciences Academic Board, chair of the Information Science Teaching and Learning Committees, and one of the 2 lead course advisors in information science for 15 years. I could go on, but I think that is enough from me. It is now time to hear from Professor Savarimuthu himself. Please join me in welcoming Professor Tony Savarimuthu.
Tēnā koutou, tēnā koutou, tēnā koutou katoa. So thank you all for being here, and vanakkam. So vanakkam is what we say in Tamil to greet people. Okay. So I'm from the land of Tamil Nadu, as Professor Barker has said. So thank you for the kind introductions, Professor Brock and Professor Barker, and thank you, Associate Professor Dick, for your final remarks and for your thank you note. So today I'm going to talk about my personal journey. So I'm going to reflect on my personal journey along with my academic journey. As Professor Barker has mentioned, these 2 journeys have been intertwined a lot in my case. So what I'm going to talk is a combination of these 2. So I'll go back and forth during my presentation. So my journey started in the state of Tamil Nadu. Tamil Nadu is the southernmost state of India. I was born at the center of the state in a place called Manaparai. It's known for a particular dish called murukku. So we all love food in India, so I really enjoy that particular dish. And my parents were teachers. So I was quite privileged growing up. We had plenty because they were teachers. We could afford good education. They could afford good education. But they have had a remarkable journey. So I really appreciate my parents because of the education that they provided, because when they grew up in a poor household. So they come from a farming background. So in India, the farmers have very little. So they had about 3 acres of land, and they have 4 kids. And in both sides of the family, they had several kids, so it was difficult to feed them. But my parents were quite determined. So they were the firstborns in their families, and also they spent a lot of time commuting to school, and they literally had no electricity. So as they were growing up, they experienced poverty, and that made them strong because they were quite determined. They were determined to get a good education. So my dad walked about 16 kilometers a day to get a good education. So they were the first in many things. My father and mother, they're both firstborns, and they were the first to go to college. They were the first to go on to become master's degree holders. So my mom has a master's degree in history, and my dad has a master's degree in English. So education was a top priority in our household. And they also made sure that we learned the lesson of perseverance. Whatever we do, we must do the best. If you're studying, we must be the best. If you're going to play sports, we must be the best. So this was something that was inculcated in us as a part of our childhood education. So I asked my mom, so what do you remember the most when I was born? And she said, lots of chaos. So I was born in 1979, and this particular space station, Skylab, was coming down. And a lot of villages had this chaos. The people were thinking it was just going to land on top of them. So they were trying to sell all their cattle, their houses, and so on. So there was a large amount of chaos. when I heard this, I thought, that was not a good start. But I soon found something good. So this 1979 was also the International Year of the Child. So that was a good year because it raised certain interesting issues about children, the child poverty, and the need for educating the children, and so on. So something good came out of this year. Then my parents moved to a almost southernmost tip of India, to the bottom of India. That's 300 kilometers from where I was born, to a beautiful place called as Vikramasinghapuram. It's closer to a place called Papanasam, which some of you from India might know. So it has this beautiful waterfall. This was 4 kilometers from us, and I grew up in the paddy fields. So literally, that is the view from my house. If I look outside, I would see paddy fields. It was such a beautiful environment for me to grow up. And this was me when I was 2 and 3 respectively. And you could see something interesting. I have a stair. I just noticed by looking at these pictures. But so this stair is harmless. I didn't know that I had this professorial stare when I was only 2 and 3, because my wife tells me, sometimes you have this stare, you just keep looking at things. I'm thinking you're thinking. So I had this right from the beginning. So I was destined to be a professor, right? So I'm just joking. And I had a very happy childhood. As you can see from these pictures, I was really smiley. And I went to Catholic schools. So this was my high school, St. Mary's. And the Brothers of the Sacred Heart were very strict. So if you've been to a Catholic school at that point in time, you'll know how strict they were. But I was a good student. Mostly, I was not punished. Mostly. And I also played some interesting sports. For some of you, this might be quite new. Probably you might hear this for the very first time. I played these sports called tennis and ball badminton. So tennis is the circular ring. We call that as a ring ball. So it has exactly the same rules as tennis, but you need to throw this ball across the net. And it was quite good in creating wobbly balls. So when this ball twists, it's really become difficult to actually hold on to the ring ball. So it's quite hard to catch it. So I was pretty good at it. And I also played ball badminton. So this is the version of badminton where we have a woolen ball. So this is pretty good because we could play these sports even if it's rainy or windy. Okay, so with shuttlecock, with shuttle badminton, it becomes difficult when it's windy. But with the ring ball in particular, we could play when it rains. So I also was a troop sergeant. So I represented my school in the national events, and I had a lot of fun with my grandparents. I said my grandparents were poor. Yes, they were poor, but there was a lot of fun. So I spent about a month every summer holiday with my grandparents. So my parents made sure that I went and learned the state of the world. I must know how the real world looks like. So they've sent me every month to my grandparents. So one interesting thing is I learned to swim in a well, because this was a very dry land. So this is the center part of Tamil Nadu. So we didn't have any rivers. It was really dry. So typically to make a person learn to swim, what they do is they tie a dried vegetable. So they tie it to the back and they just throw the person in the well. Okay. So initially for the first 20 minutes, you just cry. You cry and cry. And then suddenly you realize you're not dying. So finally, after the 20 minutes, you decide you can actually swim. Okay. So I learned swimming when I was 10. And my sister was quite capable. She just saw me swim, and she just jumped. She had no flotation device. She jumped, and then she swam. So she was a natural. Okay, I'm not natural. She is. And another interesting thing about growing up with my grandparents or visiting them is having fun in the context of riding animals. So buffaloes are really, really soft. Even though they may look really big and scary, they are really soft animals. I spent a lot of time just riding them. As they're grazing, you can just lie down on them and have a snooze. Okay, so it's really fun. So I had a lot of fun with my grandparents. At the same time, I also saw how hard they worked. As you can see here, there are a couple of AI-generated images because I don't have the real images. I learned something about agriculture as well. Because the water was scarce, they need to really plan what kind of vegetables they grow. And I soon learned if you go into the field of tomatoes, you get really, really itchy. but that's a good opportunity to go and jump in the well. So I used to do it. And I really hated plucking flowers or harvesting flowers because it's a really boring job. This would be 5 or 6 hours long. So I did realize what I liked and what I didn't like. But more importantly, I realized the transformational power of education. The reason why we had a comfortable life is because of the education of my parents. So I didn't take it lightly. So I did work hard, and I topped the class both in my 10th standard and 12th standard. So these are the 2 public exams. And there is this article in the newspaper where it says, I wish to become a doctor. So at that point, what I meant was medical doctor, not the kind of doctor I had become. Okay? But I'm happy with the kind of doctor I have now become, but that was definitely the medical doctor. And I had a 95% score in my 12th exam, but still that was not good enough to become a medical doctor. But I had several offers in engineering, so I got into mining engineering, computer engineering, chemical engineering, and so on. And I decided to take up chemical engineering because that was my second favorite subject. I really wanted to become a doctor, but eventually I became an engineer. So the reason why I chose chemical engineering because of my love with organic chemistry. For some reason, I really liked organic chemistry. I think my teacher had a big role, and salicylic acid was my favorite compound. I don't know why. So I moved to the northern part of India. So we were in Tamil Nadu, and I went all the way to Rajasthan. This is 3,000 kilometers long. So the journey was quite difficult because you need to take 2 buses and 2 trains. And it took 3.5 days to reach Rajasthan. And I became an expert in taking these trains. So some of you here who may have taken Indian trains, they're usually punctual. So it might be a maximum of 4 hours late. So the Nellai Express that takes you to the city Chennai, and then the Grand Trunk Express takes you all the way to Delhi, and then you need to take a bus. So I would have spent about 2 months commuting to the university, just going to the university and coming back to my hometown, because I was at the university for 6 years. And I chose BITS Pilani, the Birla Institute of Technology and Science, which is difficult to pronounce. And this was set up by the professors in MIT. And this was one of the prominent universities in India, and that had become the most modern engineering school in India. So that's the main reason why I chose to go to BITS. And I studied chemical engineering because of my love with chemistry. But I soon realized chemistry and chemical engineering are 2 different things, even though they have chemists somewhere in their titles. And it was all about the large-scale production. So the reason why I was interested in chemical engineering is a distillation column where we have a petroleum-heavy residue, and the petroleum-heavy residue can be then distilled into kerosene, petrol, and all kinds of interesting liquids. So that was my main attraction to chemical engineering. So as a part of any engineering degree, you had to spend a substantial amount of time in internship. So I did my internship in the east part of India, in a state called as Bihar, and now it's a part of Jharkhand in India. And the institute called Central Fuel Research Institute was located in this town called Dhanbad, meaning a city of wealth. So they had become wealthy because of coal, and that's the reason why that research institute is located in that town. But soon I became really sick. I was asthmatic. So I had probably 6 to 7 episodes of asthma in 6 months, and I had to change my mind. So I decided to do software engineering. So again, I went to university. I finished my first degree, but I went to the same university back, and I had a conversion program where I took software engineering. That's how I became a software engineer. And my first taste of research came in the year 2001, where I was a graduate assistant or a teaching assistant in a software engineering, for a software engineering paper. So what is interesting about these 2 graphs is students, as a part of their study, have to estimate how many lines of code they will write before writing the code. Okay, this is a part of the software, personal software process. And also they have to estimate the amount of time taken. So these graphs show that students can do more in less time. So sound familiar? So we're all actually probably do the same thing. We think we can do more in less time. So these graphs show that. And it is an example of a planning fallacy, according to Daniel Kahneman. Especially, we underestimate the amount of time taken. So one thing that we can do to prevent this is if you systematically collect metrics, we collect data over time, and then if we know that we are constantly underestimating, we can add a buffer, we can do better. Okay? So that's the first taste of research for me. And I didn't want to miss out on the industrial experience. So after I graduated, I took up a job in Chennai. So I came back to the city of Chennai again, and the city of Chennai, formerly known as Madras, is well known for its tech hubs and the beautiful vegetarian food served on a banana leaf, which I still miss, and the Chennai Super Kings, for those of you interested in cricket. Okay? So it's well known for all these three things. So when I was in Chennai, I had two jobs. So I had a weekday job and a weekend job. So you can see Midjourney has produced beautiful images of myself. Actually, it's not Midjourney, some others, Flux LoRa model. So you can see it is pretty accurate. Those of you who actually know me 25 years ago, probably look the same. But I know that these are not real because I'm not a Mac person. And this hand is not mine. I can look at it and say the hand is not mine because this was trained based on just 12 images, okay? And I didn't provide anything with my hand, so I know it's fake. So I sent it to my sister, and then she immediately said it's fake. It's not you. Okay? Right. Okay. So my first job as a software engineer was on diamond processing. Actually, that was quite exciting because I learned something about the domain knowledge. And it is an amazing world of diamonds because not many people know that 90% of the world's diamonds are processed in India. And it is a really lucrative industry. And we were working on automating that industry where you take a diamond stone and it is usually cut into many pieces. And it has amazing properties. Usually colorless diamonds are the most valuable diamonds. If there is some tinge of color, that's useless. So they processed it into many chunks, and then these artisans worked on many devices, many instruments to polish it, and then finally you get a really shiny diamond. So my first job was in business process automation. So we converted the plant from paper-based system into an electronic system. And as I was working as a software engineer, about 1.5 years into the job, we have completed the project. But the next project, surprisingly, was the same project for a different plant. So now that we have completed one project, they wanted to do the same thing over and over again. It made a perfect business sense, but it was not exciting for me. So I had to make a change. So I really liked teaching at BITS Pilani, so I was applying for PhD programs everywhere in the world. So I got admitted into 4 different countries, but I chose to come to New Zealand. The main reason was it had the only program that offered software agents. So there was a software agent research center. Some of you might know 20 years ago, Professor Martin Purvis and Professor Stephen Cranefield created that center. And I was quite excited because I wanted to do something in software agents. I don't think there were a lot of other Australian universities either. So out of all the four programs, this is the only program that attracted me, so I chose to come here. Another reason is Professor Stephen Cranefield, because he was quite good in answering my emails. So that's one of the main reasons why I came to Otago. And I was supervised by these 3 beautiful people. I really admire them. They all have their own strengths, a lot of different strengths. And they became my supervisors. And Dr. Mariam Purvis was my primary supervisor. I didn't meet her as a part of my interaction, but I met her once I reached here, and she has been amazing support. Thank you, Mariam, for being here. And my PhD topic was on business process modeling. Surprise, surprise. It's the same as what I started. So here is a business process model. And it is modeled using a technique called as colored Petri nets. Interestingly, colored Petri nets does not have anything to do with those colors. Okay? It's a formalism. And my job was to take this colored Petri net and then create this agent-based system where each of the tasks in green can be encoded as an agent. So there are lots of different agents. Each agent does its own thing. So we're moving from a centralized system to a decentralized system. And there are a lot of advantages. For example, we don't have a single point of control, failure in terms of a workflow. And also we can spawn a lot of different agents. And when you have different agents, we can solve the problems more efficiently and so on. So that was the start of my research. But something interesting happened. In 2006, something happened. Before something happened, I wanted to introduce you to the concept of software agents. The software agent is a program that acts on behalf of a user or a program. So you can think of robots. Robots are the easiest to understand because robots do something on our behalf. There are firefighting robots, there are the industrial robots, and so on. So these have very interesting characteristics. So we have to design these agents using human-like characteristics, and that appealed a lot to me, particularly the social ability and the learning ability. So Stephen went to a conference. We actually shouldn't send academics to conferences because they change topics. I'm just joking. We should definitely send academics to conferences. I'm shooting my own foot here. So he went to a conference and came back and said, can we actually design agents that are socially capable? So you see a robot there shaking hands, right? But at the start of this lecture, I said, "Vanakkam." So there's a different way of greeting. But if you went to Japan, there will be a bow. So there are social norms. And these robots, if they're going to live with us in any shape or form, we have to teach them to be socially capable. And that was the birth of sociability for me. So I changed my research topic. I don't think Mariam was very happy. Sorry, Mariam. But I think you got used to it because I was so passionate about it. Thank you for understanding. So sociability is not only the ability of the agent to be friendly, it's the ability for the agent to communicate, cooperate, and coordinate. At the heart of all of this is social concepts. There are a range of social psychological concepts that we use as humans. As humans, we are very good with social norms. We know what to do, what not to do. We have values such as honesty, integrity, freedom, equality, and so on. We have reputation systems. So we know what kind of reputation to assign to different people. Of course, we don't say it out aloud, but we know certain reputation. We have reputation for other people. We have the notion of trust. We have preferences and so on. How do we make all these concepts computational? If you're going to create a software agent that is computational, all of these concepts should be translated into software programs. So that's the kind of sociability I'm talking about. So as I was learning about the social ability, some changes happened in my social world. My sister Sharmila, who's been following me all around as I was growing up, also decided to join Otago. So she also joined our same research group under two of the same supervisors as Professor Barker noted. And while I was working at social norms, she was looking at reputation. So it was a family venture. We were looking at different social topics. And I got married to her best friend. She introduced me to Rexy, and we got married in 2007. And they got along famously, but they gang up upon me. So I wouldn't recommend marrying your sister's best friend, okay? Those of you who are single, please don't do that. And in 2008, my son was born, and we are also quite famous in getting into the newspaper because we time things right at the right time, and he was a Christmas baby, so he appeared in the newspaper. And my sister and I, we graduated in 2011, and one thing I learned on my graduation day was about sibling rivalry. So she was always behind me, and she would always follow me and beat me to it. Right? For example, when I was swimming, I was 10 years old, and then I needed a flotation device. She did not. She just jumped into the well and she swam. And then when I left the job in the software industry and came to Otago, she took up the job in my company. Okay? And in Otago, she came and joined the same research group, and she had a scholarship, but I didn't. Okay? So she always had this ability to excel in whatever she wanted to do. And I waited for her to submit her thesis and fulfill the requirements to graduate. So I waited almost for a year. So something interesting happened in the graduation ceremony. Because of the alphabetical ordering, she graduated first. And then she came back to me, I bet you on this one too. So Another lesson, don't trust your sisters. Okay, they always have this sibling rivalry. And my family grew. So I had two beautiful kids, my daughter Ria and my son Rohan, and my family started growing. So paralleling the growth of my social life and my family, I grew in these three areas of my research. There are three different branches of my research. So I'm interested in socialness in software ecosystems. So what are software ecosystems? So similar to the natural ecosystems that we live in, where it has some core components like wind, soil, and air, and water, and so on, and a set of living beings and non-living beings, and the interactions. There are different kinds of interactions. There are social interactions, chemical interactions, biological interactions. Similar to this natural ecosystem, I'm interested in software ecosystem. Of course, software ecosystems are artificial and man-made ecosystems. At the heart of these ecosystems is software, but software is not a solo entity. Software is made up of other software called libraries, and the software can be part of another piece of software, so it's a complex entity. The software is not a siloed entity. It is actually an interconnection of multiple entities. And these run on a range of devices, and then there are lots of people who are interacting with these devices. And I'm abstracting the software ecosystem into these three layers. At the heart of a software ecosystem is a software, which you see in the center, and then you have two other layers, the software development team at the top, and the set of users at the bottom. So it's an abstraction of a software ecosystem. And there are also these interactions between different layers, vertical interactions, horizontal interactions. So I showed this particular slide to my son, and he said, "Dad, what is a Pokeball doing in your presentation?" Actually, it was unintentional. I had no idea that this was a Pokeball. Okay? And my interest in software ecosystem is in these three layers. In the first layer, in the core layer, I'm interested in how do we make software more socially capable. And in the second layer, I'm interested in what is the socialness among software developers. So it's this layer where we have a set of software developers interacting with each other. And the last part is how can we create software that solves some of the social issues? So it targets the users of the society. So in the rest of the talk, I'm going to spend time in giving you a glimpse of what I did in all these three different areas. So the first theme was on developing socially aware software, which is at the core of the software ecosystem. So these are some motivational scenarios for creating socially aware software. In the future, there are going to be a lot of different robots in healthcare, in customer service, in education and entertainment. And all of these pieces of software should be socially capable. So not only for robots, but also for artificial agents such as these avatars. There are non-player characters. Non-player characters can learn from the regular players, the human players. For example, the norm of cooperation. So they are cooperating to fight this evil dragon. Together, they are defeating the evil dragon. There's a norm of cooperation. And we also have these smart devices, which should be socially capable. For example, if you have an awkward or a shy teenager, there could be a program that helps him or her to be more sociable. Okay? So these are some scenarios for creating socially aware software. So the first question that I asked was, how do we develop computational approaches for normative decision making? So I'm interested in social norms, and we're all aware of social norms. So these are your do's and don'ts. So as we grow up, we learn these social norms. So some common classical social norms are prohibition norms and obligation norms. So prohibition norms are those norms where we say, do not litter the park, so don't do something. With the obligation, we are expected to do something. You ought to tip a waiter for a good service. Of course, it's not a norm here, but it's a cultural norm in the United States. And then these norms are violated, there are sanctions. Now, how can we bring the concept of social norms to software agents? How can a robot learn to behave socially? For example, if there is a robot sitting here, how can we program that agent so that it is socially capable? So that's what I've been interested in the last 18 years. So we created an architecture we were the first to propose this norm identification architecture where it's based on a set of observations. If there is a robot sitting here, it should be able to infer the norm of this place. Say, for example, it must infer that at any point in time there is only one speaker. And if you are going to ask a question, you're going to put your hand up. So can it learn based on these observations? So an agent looks at the whole world and observes and then identifies certain norms. And that's the concept of norm identification. And we designed an architecture. I'm not going to go into the detail. So this is we develop an architecture and then implement software code that runs this particular architecture. So this is based on a set of observations. So there are a set of events that happen in this environment. An agent records all of those interactions as event episodes. And then there are some special events that happen. For example, a sanction is a special event. When somebody sanctions saying, hey, don't speak, and so on. So there might be yelling, there might be some signals, nodding of the head, some disapprovals. These are sanctions, and the sanctions form the basis for norm identification. So based on a set of observations and a set of sanctions, we use a norm engine to identify norms. So prohibition norms can be identified based on what an agent did, and as a result of that action, it got sanctioned. For example, if you're littering, you might be sanctioned. In an obligation norm, it is the failure to do an action that causes a sanction. For example, you did not tip, therefore you got sanctioned. So prohibition norms and obligation norms are the inverse of each other. You can write in a logical way, you can write the same thing in two different ways. Now I'm going to give you a glimpse of what I did to encode this in the context of a software agent. Let's take this scenario of park littering, where an agent or a set of people are walking in a park and they have a sandwich and somebody drops the litter, the wrap, and they get sanctioned. Now I'm using a very simple example which is made up of only 3 events. So the first box here shows a set of events that an agent observes. So the first observation is a software agent observes the world, and what is happening is an agent eats, it litters, and it gets sanctioned. Okay? So it's a very simple model, and based on observing all of these particular sanctions, then what it does is it does some computation. In this case, it looks at a window of history, so it can look at 3 events or 5 events or 100 events preceding a sanction, and then it uses conditional probability. So conditional probabilities are amazing because we can turn these into numbers, and then what comes out is conditional candidate norms. So in this case, after deliberation, after working out conditional probabilities, a set of candidate norms come out. And when we have a set of candidate norms, we can prune certain candidate norms. In this case, I can prune out all the other events except the littering action. That is because whenever we eat, there are not a lot of sanctions associated with the eating action. So we can actually eliminate E. If you eliminate E, we can actually eliminate the sequences EL and LE, and then we can identify the littering norm. So now you might wonder, why don't we just give the norm to the agent? Okay? Now, if you give the norm, then that's not a good approach, because typically for every action, the agent is going to ask you, is this a norm? Is this a norm? Is this a norm? That'll be quite annoying. So we need some learning capability where it learns this norm, and then it asks the human, is this a norm? Is littering the norm? Because I have learned it. So that's a better approach for norm identification. That's why we started with sanctions. So give you another example. So this is an example of obligation norms. So tipping in restaurants, in tipping in restaurants, the sanction happens because tipping did not happen. So in prohibition norms, there is evidence for an action that has happened in the past, which is the reason for a sanction. But in tipping, it's the lack of evidence for a particular action. The action did not happen, and hence a sanction happens. So it's a little bit more involved. So we look at even history based on observations, and then we divide it into 2 different lists, those with sanctions and those without sanctions. And then based on even sequences that are with sanctions, we again work out some conditional probabilities, and then we work out the events with top probabilities. For example, in this case, an agent pays and it departs, but it forgot to tip. Okay? And that is the reason for a sanction. So we know that there is something interesting with this particular event sequence. So what we do is we again do some magic. We identify supersequences of PD, the pay and depart. The supersequences always include the tipping action, and that's how we identify obligation norms. So we have proposed certain mechanisms which can then be tried across a wide range of scenarios. So I'm going to show you some simulation scenarios where agents identify norms. Of course, buying a robot is quite expensive. Probably Brendan knows it. It's really, really expensive, so we resorted to simulation because after all, we are designing software and we can simulate software. Okay? We don't have to deploy it on hardware. So here is a scenario that shows prohibition norm identification. So here are a set of agents that run around, and when you see a square, a red square within an agent that actually marks a norm that has been identified. This green agent has identified a red norm. The red norm corresponds to the prohibition norm. So there is one interesting observation. When I was doing this was a part of my PhD work. When I was doing this, Stephen used to tell me, oh, that's a torus. It's a toroidal grid. And it took me a little bit of time to understand what he was actually referring to. So one day I really understood it because it's nothing but my tenicoid ring. Remember the tenicoid ring? A toroid is a tenicoid ring, the rubber ball, which is actually, it wraps around, right? In a simulation model, you wrap this around to the bottom and you wrap this part around on the side. So it is actually a tenicoid ball, okay? So there's a link between that game and my simulation. So here's another example of obligation norms. So in this case, it was a simulation of the tipping norm being identified. There are lots of agents going and having meal, and then they are sanctioned by these blue agents who are the waiter agents, and eventually the norm is identified. So most of my work uses simulations. Okay. So I'll stop it there. So that was one approach based on sanctions. Another approach in real world is we are influenced by others, by leaders, and then we take up the norms of the leaders. So we developed another approach called a role model-based agent mechanism approach, where norms propagate on a network topology. So we created a simulation panel using a particle collision model. When two particles collide, that represents the interaction. The more particles, the more collisions there are, an agent travels faster, so it creates different kinds of network topologies. This is very similar to what Professor Peter Wiggum was talking about in his IPL. So we have a mechanism for, again, creating these network topologies, and then based on these topologies, then we see how norms emerge over time. So it was another mechanism for studying norms. So more recently, we have been working with colleagues from Massey University on the use of large language models. So I have to thank Sean He and Surangi Karanatunga from Massey for this joint work, where we have been looking at social norm competence in large language models. This is also joint work with Stephen, where we found for a very simple problem, the problem of norm violation detection, GPT-4 is pretty good. So it identifies, in 86% of the cases, all the 10 norms that are violated. So we gave ChatGPT 10 different norms, and we created stories, 80 different stories, which had norm violations, and ChatGPT was pretty good. So it was good in most cases, but there was a lot of hallucination that we did see. It was trying to invent more details. And we also saw that it was able to identify more prohibition norms than obligation norms. It is possible because we are, as humans, we usually say, don't do this, don't do that. I do that to my kids all the time. So possibly there is a bias in the data set. And this has been a prolific area of research. We have published 45 papers. It's widely, many of our papers are highly cited. And many of our papers appear in survey papers which talk about this particular field. So now we quickly pose some remarks. So I have been working in this area for 18 years, but still it's an emerging research area. One of the reasons is that people work in silos, and we often look at only one social concept. For example, for most of my career, I've looked at social norms. And Sharmila has looked at reputation. But we hardly integrated these two. And Stephen and I are interested in the concept of trust, but we haven't had the opportunity to study trust. So what I'm trying to say is there is a wealth of further research that we can actually pursue if you combined all of these, because humans are so socially intelligent, and we are intelligent because of all of these concepts, but in the context of social computing, we need to integrate all of these concepts to really make agents really sociable. And there is a lot of scope for interdisciplinary research, from sociology, psychology, and even within computing science, because we can integrate vision, we can integrate deep learning, and so on. Now into the second part of my research. So the second part focuses on the socialness of software development teams. So for many of the projects, I've worked with Associate Professor Licorice, who's here. Thank you, Sherlock, for many of the projects, for the collaboration. So we looked at these rich interactions that happen in software development. So one of the advantages working in the software engineering field is the large and rich data, because software development is a social activity. There are huge repositories of code, who wrote what pieces of code, bug repositories, email repositories, and so on. So there is wealth of data that is available. And we can look into these social interaction data to mine insights. So I'm going to highlight a couple of projects from my PhD student, Pankaj. So here is a mushroom diagram. We have created lots of these mushroom diagrams, which are actually interaction diagrams between developers when they work in different communities. So this is the Python developer emails. So as a part of developing the Python language, the developers interact with each other. And there are 4 different communities. And this paper looked at identifying boundary spanners. Boundary spanners are these people who contribute to more than one community. So these are significant people who are responsible for keeping the whole project together. So they're responsible for the success of these projects. And we identified the prominent boundary spanners who span across all the 4 communities. And we also looked at what happens when somebody leaves. For example, if these 2 people leave, Guido van Rossum and Martin van Looy, if these people leave, who should now become the new administrator? Because these are open source communities, anyone can leave at any point in time. So based on the network topologies and also the interaction structures and different centrality metrics, we proposed an algorithm, and we found Nick to be a suitable replacement. So Nick Colan is a prominent developer from Australia, and our algorithm recommended it's Nick. So after this project was published, what happened was Guido van Rossum, who was known as the benevolent dictator for life, he created the Python programming language. He resigned. So he couldn't just take it anymore, so he resigned. And in fact, Nick Colan was chosen as a member of the Python Steering Committee Council. So there was a good acknowledgement that our approach worked. Of course, this is only one acknowledgement. We really don't know if others leave whether the same mechanism works. But this was a good acknowledgement. And a second project involved mining hidden decision-making processes. So a lot of decision-making process in open source is actually hidden, and they lie hidden in email repositories. So here is a process that describes what happens when a decision is being made in Python to develop a new module. So whenever a new module has to be developed, they follow this process. So initially somebody proposes a draft, it gets accepted, sometimes it gets rejected, it moves into the final state when it gets implemented, and so on. So there are different states. And we wanted to investigate, is this what really happens? This is what they've advertised that it happens. Can we actually mine this exact process from data? So when we did data mining, we found that the process was not exactly the same. It was quite different. There are new nodes, there are a lot of connections, and so on. And things get quickly more complex because we also wanted to study what happens between the draft and the accepted state. So what are the decisions that have to be made between a document being in the draft state and the accepted state? And it gets really, really complex. So this is only in the 20% zoom level. It was 5 times more complex than this. It's a really, really complex process, and we use a process called as process mining to extract all the decision making that happens. So Pankaj managed to aggregate some nodes, prune some nodes, and he created this beautiful diagram which actually shows the decision making process in Python. And we verified this process by sending this to the Python steering council, and they said, oh, that's a beautiful diagram. So we knew all along this was happening, but you have made it more explicit. So that was an acknowledgement that we were doing good research. So now I'm moving on to the third part of my talk and the third part of my research. So this is something that really excites me, because here we are working with AI software. We are creating AI software for solving social issues. So this has been motivated by Mariam. So thank you, Mariam. I think right from the beginning, when I joined the team, and she has always been interested in social issues. So thank you for inspiring me. And the first paper was with my wife and Mariam. So we looked at this particular issue, that the crime data is not open source. So in some countries, crime information is available online. For example, in the UK, if you go to UK, you can actually find crime maps for every city, every road, and so on. For example, are you safe in Octagon at 3 a.m. on, say, a Saturday morning? So we can answer those questions. And the data lies in newspaper articles. So we looked at the newspaper articles, and we used a technique called conditional random fields to extract where these crimes happen, and then we map it on top of a map. So this is a useful thing, and Rexy found it really useful because she was always scared when I went to a conference. She would always say, "Are you safe? Are you walking by yourself?" So that's a good use case for this particular project. The second project is the project of Jitin, who is actually sitting here. Jitin was a PhD student, and we were interested in offensive language reduction system, and this was mainly motivated after the Christchurch attacks. There is a large amount of offensive language in online social media. So in this particular project, we looked at offensive language in Stack Overflow. So what he looked at is, first of all, what kind of offensive language exists, whether it is an offensive language or not. When a comment is posted on Stack Overflow, we can classify whether it is an offensive comment or not. And on top of that, we can classify it into different types, whether it's targeting an individual or whether it's racial or swearing. And on top of that, we can identify what is offensive. We can highlight the words that are offensive. For example, calling someone "you idiot" and so on. And on top of that, we can actually rephrase those comments into non-offensive ones. Okay? So he, in his PhD work, he looked at a range of machine learning algorithms that can do all these 4 activities. And for this work, he received the Exceptional Thesis Award. And he also developed a software prototype which can actually do all of these 4. And the third project involves reducing data waste. So we introduced the concept of data waste, and I am guilty of reducing data waste. And I think many of you may be guilty of doing the same, because I take too many pictures of my children. And I also take lots of videos, and I not only store on my phone, it is stored in the cloud. So we produce a huge amount of data waste. And in this particular project, we looked at data waste in the context of comments, comments for app reviews, comments for hotel reviews, and so on. So on the left, you have some useful comments, because you know what is a problem in an app review. On the right, you have some comments which have no informational value. Calling an app to be dumb app or a total waste or too bad, cannot do much with this. It's actually a waste because already this information is captured in the rating, because the rating is a mandatory field. If it's really poor, you might get a rating of 1 out of 5. So this information is already captured, but the comment is not really adding any extra value. So it's useless. So we developed a set of algorithms, machine learning models, and we showed this problem can be solved. And we also quantified the sustainability implications. So just by saving these reviews from being produced, so if we educate a particular user not to post a particular comment, we can actually have substantial savings just in the app review domain alone. But I believe we have a lot of scope for sustainability savings, cost savings, time savings, and CO2 emissions if we all decided not to create data waste. So one last project before I finish. So this is a project that is quite close to my heart, because this is about energy poverty. So I saw energy poverty firsthand, not only from my parents through their experience, I also saw that in my grandparents. They didn't have electricity, but I had a good time. Of course, I can't deny that because I was growing up. I was just a visitor for a month. So this is closer to my heart. So in New Zealand, there are about 100,000 households that suffer from energy poverty. And this is a fairly recent project where the goal is to identify energy poverty. Energy poverty is often a hidden problem because people don't want to publicize that they have energy poverty. So how can I use artificial intelligence algorithms to detect energy poverty? So in this case, in a smaller data set, we could identify or cluster people with energy poverty. And on top of that, we could look into behaviors. What kind of behaviors are exhibited if they have energy poverty? Do they turn off water heating? Do they turn off space heating and so on? So that's shown by this particular clustering. So our goal here is to use AI approaches to somewhat reduce energy poverty. Can we suggest the time of use for energy? Can we actually use energy microgrids? Can we get cheaper prices from energy microgrids and so on? So this is a project that I want to invest more time in the future. So hopefully I have given you a glimpse of all the three areas of my research. But the key theme that underlies all of these three different branches is the ability to be social. The ability for a software to be social, ability for the software developers to be social, ability to create software that can solve social issues. So I want to leave you with some take-home messages. So the first message is creating socially aware software is becoming more and more important. We are going to have a lot of devices that should have this social capability, not only robots, but also our mobile phones, our smart speakers, and so on. And in the second branch of my research, I looked at the social interaction data. There is a large amount of this social interaction data, and from this data, we can unearth some key insights. For example, we can unearth hidden decision-making processes. And in the third branch, which is actually closer to my heart, it is all about creating software that can solve social issues. For example, how can we detect and reduce energy poverty? And all the three areas are quite exciting to me. I do not know what I would prioritize in the future, probably work on all these three areas. If there is one message that I want all of you to take away, it's this one. Sociability is a key property, not only of humans, but also software. So in the future, we are going to create more and more software which is socially capable. So with that, I have a lot of people to thank. First of all, I would like to thank my mentors, Professor Martin Purvis, who would have really loved to be here, and Dr. Mariam Purvis, and they played an important role shaping my career early on. And I would like to thank Professor Stephen Cravenfield, who has been my mentor and a supporter throughout my career. He has been my champion at Otago. So thank you, Stephen, for being very supportive throughout my entire career. And I just realized that I have 98 collaborators. I couldn't find all the pictures, but I would like to really thank all my collaborators, and particularly Sherlock for all the contributions. We have published more than 25 papers. And interestingly, I also saw that I recently noticed that with Martin and Mariam, I published more than 50 papers, and with Stephen, more than 30 papers. So they have been substantial contributors, so a big thank you. And I also want to thank all my PhD and master students. Their success has been my success. So thank you all to all these students. So I want to also thank my honor students and my research students. I can see someone here, Shamalima, thank you. And to all my colleagues, all the HODs of information science, all the former PVCs of commerce, all the former colleagues in information science and computer science, and my colleagues at the School of Computing, and Associate Professor Grant Dick, and the academic party today, thank you. And finally, I also want to thank, I want to thank my parents, who have been my rock and my supporters, and my family, Rexy, for your support, and for your patience, and for your kindness, and for all the sacrifices for our family. And I also want to thank my children, Rohan and Ria. Thank you for providing me with the necessary distractions. And I also want to thank my sister Sharmila, and brother-in-law Ruben and family, and also my brother-in-law Robin and family. And I also want to thank my prayer group. They have been a substantial part of my journey. I thank them for the spiritual food and also the real good food that we share at times. And finally, and most importantly, I would like to thank my Lord and Savior Jesus Christ, who is the true source of intelligence. I've been working with artificial intelligence, but I strongly believe it's Him who's the source of true intelligence. With that, I would like to thank you all. Nami Inui, thank you very much, and Nandri Vanakkam. Thank you.
Tēnā koutou katoa, ko Grant Dick, taku ingoa. Before I start, professors, tēnā kouroa, and Professor Savarimuthu, kia ora. Well done. So hello, I'm Grant Dick. I'm the head of school here at the School of Computing here at Otago. It's my job now to, well, it's not really a job, it's a privilege and a role, to give a little context on Tony's talk, although I think it was actually very well contextualised. But I'll also perhaps just very briefly talk a little bit about Tony and his life here at Otago. It was mentioned that Tony actually started in May 2006, and I know exactly the date because it was exactly the same date that I started as a lecturer. So I've got a little bit of a bond there personally, and also I remember as a PhD student the many times we had here, and I'll probably start actually with the discussion here with Tony as himself. Okay. Tony has alluded to in his presentation there many things that have actually shaped his perspective, including the strong familial links that are great to see here today. So it's great to see everybody here. I don't mean to single out, but I will anyway. Our particular interest is Shami. As has been mentioned here, there is a bond there of how you have studied and sort of worked together. I've put here as perhaps not fully appreciated, but I think you fully appreciate the fierce sibling rivalry that no doubt led to both of your successes. From a department perspective, I'd like to point out that I wasn't actually here for this particular instance, but the fact that I know about it tells us about the severity of it. And I've heard that there have been new rules in place drafted for the social cricket events that take place at the writing retreats because the two of you were made captains of opposing teams and couldn't actually resolve anything. Okay. But more seriously, clearly there's a very strong family value that is strong within you, and that impact has really impacted on the way that you conduct your day-to-day life and your professional life. You are held in extremely high regard by the students. Comments, as Professor Barker alluded to, in your teaching, showing real pastoral care and development to ensure their progress, and the many reports of bringing research into your teaching, particularly at 100 level and the likes of Comp 120, where doing so is remarkably difficult. And anybody knows actually trying to communicate your research at 100 level to a meaningful standard is very hard, and you do that very well. So thank you very much for doing that. Your strong work ethic is indeed borne out in your teaching. I was going to make a joke here about an email that you inadvertently hit reply all to instead of reply, where you said, please don't make me teach Business 106 in 2012, which I vividly remember. However, I can't think of a year since 2012 that Tony has not taught in at least one of our large 100 level classes and done so to an outstanding level, as again alluded to before. Most importantly, I don't remember a single time where Tony has done this with any form of complaint whatsoever. And in fact, I'm really not sure I've ever heard a complaint come from you at all. So again, your input into these 100 level classes and the ongoing sort of development that you do in these classes and so forth is very much welcomed by staff and student alike, certainly from the students that are taking the papers, but the staff that get to benefit from the developments at 200 level and the outcomes from those students at 200 when they arrive at 200 level and beyond. So thank you, Tony. Moving on now to service in the Information Science Department, now School of Computing, and the wider university, the level is outstanding. It's simply outstanding. There are a few people in the university environment that I believe understand the subtleties around curriculum and student development as well as Tony does. And I say this from first-hand experience from being on the promotions committee in Commerce. The phrase, "Don't worry, Tony wrote this," was met with several sighs of relief on more than one occasion when we were there. So, in fact, I once joked to Tony, I'm officially claiming it was a joke now, but at the time maybe not, that I said he was putting a massive target on his back because of the quality and attention to detail in his proposals. They were so good that they were making us all look bad, and maybe he could tone it down a bit. Thankfully, you didn't listen, so we're very happy about that. And as a result, Tony has steered and continued to steer the curriculum around software engineering at Otago. And Tony is really leading the way towards making software engineering internationally recognised and a flagship program here at Otago. There are few people with the patience and persistence of Tony to see this through, so again, thank you very much, Tony. I'll keep this short because we all want to head over to the staff club in a minute. So the last thing I'd really like to reflect on is Tony's themes of research, and Tony has really put some good detail into his presentation today. Again, showing your good attention to detail and all of these things. But I think by focusing on norms and bring a social presence into software, Tony really is at the leading edge of what is an interesting field that warrants closer inspection and embracing by a wider research community. We race ever closer to autonomous software systems guiding our lives, such as ChatGPT and related systems. These systems lack the ability to fully appreciate norms, customs and expectations of their users in a changing world. The current approaches that we use of guardrailing require laborious efforts staffed by thousands of workers in potentially unsavoury circumstances. Moreover, they're not reactive, and they can only be effective in correcting erroneous system behaviour after the fact. The research by Tony and his students really shows promise in providing true norm identification and adaptiveness in these systems. And for our own sakes, I look forward to seeing the continued development of these techniques. Please keep going. So, with that in mind, it's now my task to invite you all to the staff club for light refreshments and some further discussion with friends and family. And that will commence at the end of this, straight after this, so please head over to the staff club. So in wrapping up, I present Tony with the customary token of appreciation from all of us. And as I do, please join me in congratulating Professor Tony Savarimuthu.